but I cannot do task. I can do something like so I will have, if I have to say this array, which will have A, and let's say I have, then I have okay. And I have let's say 2p. For me, I can do the tasks as A, but I cannot do another A after it. So I have two choices. Either I go idle or I go with B. But here is the thing. I cannot just go idle because it tells me here is the cooling period between each task of each type. It can be changed over time. So it's not just it has to do like only one or only two. No, it has to be a very specific cooling period. It can be two. It can be one. It can be three. Sometimes it will be seven. So the cooling period change before I can do tasks of the same type. Um, if I am not like if can you hear me? Can someone?
Yes, we can.
Okay. So right now, let's say I have the idle time is n equal 2. So I can do after the A, I can do B. But can I do now A or not? Can someone answer me? Anyone answer? Right in the chat.
Yes, I think yes.
Can I do now another A or I have to wait? What's the next step now? Just to make sure I explain it actually in a way you understand. No one's talking.
Okay, if I might say something, the n is how many tasks you can fit between two identical tasks. So, for example, if you have A, you must wait 2 or n many tasks between it and another A.
So basically, I have to give it a cooling period or what we call idle before I am able to do another A. So I will take this and say, let's say I then before I am able to use another A. And then let's go for B. And then now I cannot, B is done. B is done. I have the B to be done. I have 2A done. I only have 1A left. Can I do it now or do I have to wait? Guys, anyone? I will answer myself. I have to wait another idle before I am able. All right. Basically, the problem. They are giving you an array of tasks. It could be, it could have A, like this, 3As, and then 3Bs. And you have a cooling period. In this case, the cooling period is 2. What they are saying here is an explanation is you can do A, then B, then idle. This is a cycle. Before you can do another A, B, and then idle. But you're not done with the. So let me do something. let's say I have an array of 5A and 3B and 2C and 2D. And let's say I have an n of 4. So in this array, basically I have 5 of 5A. I have, actually let's make it 4B. I believe it was 4B. And let's say I have 4B and I have 2C and 2D tasks. That's basically what I have. Between each A task, I have to have four times. So let's try it something like this. I have to have A and then B and then C and then D. This is waiting 1, 2, 3. So I need to remain idle, give it a unit of time, an idle time to remain, like just stay still before I go to another A, before I can use another A. In that case, now the A is, I remove, like I reduce the number of tasks I have left. So now I only have 4A, 3B, 1C, 1D. In the next cycle, I will have to go, which will be basically another A, another B, another C, another D, and another one that is gonna be idle. So in this cycle, now I have 3 A's left, 3 task A's left, 2 task B's left, 0 C, and 0 D task left. So in the third cycle, I will have to use A and B. So now A2 A will be 2 and B will be only 1 left, but I don't have a C already. So I will have to remain idle for the other, for about 3 unit of time. I cannot remove until another 4 cooling period has passed. See this? This is called cooling period. Now, in the other, in the another cycle, it will be, I will have it here as 0, but I only have 1 left and nothing else after it. No A after it. Am I? No, actually, it's not correct. I did miss one. I did miss one because I still have 1 task left. So I will have to remain idle for about another 4. Before I can actually finish the only 8 task left. Do you understand what I'm trying to say? Anyone?
Yes, understood.
Okay.
Yes, we are trying.
So this logic, if we count it, how many period do I have to at all till I finish all the tasks in this array? We just counted. The first one is 5, then 10, 15, 20, and 21. So I'm not gonna like do the code now. I will just say something. Let's say return 21, and let's try our if to see if actually our logic is correct. So let's say now it's 4 and it's 5A and we have 4B. I believe I was wrong. And we have 2C and 2D. And let's give it a cooling period of 4. Am I missing something?
I'm not sure they might accept the lowercase.
Oh, yeah, okay. That's because it will mess up. Right, so let's make it all uppercase. I don't care about, I haven't tested for the other case. I'm just like, this logic we're following here, this is the correct logic. I haven't solved anything yet. So now we have to think about how do we approach this problem. So basically, my first thought was like, okay, I'm gonna need to know the number of unique element, and I'm gonna need to know this hash basically is what I'm gonna have to work on it. And I'm gonna need to know what is the most frequent element in it. Because if I started this solution with like 2D, so if I started with 2D, I can do it, but it will not give us the minimum. Because it's basically, I will start with, let's say, I will start with D. Let's say after it, I will start with C. Then, actually, in most cases it will, but let's say it's much smaller than this, and only have, let's say, 1D. So if I started with only 1D, it's not gonna be very efficient. So I need to know what is the most frequent element I will have to actually have. It is the one I'm gonna need it more to finish the cooling period. So my thinking is I'm gonna use a counter to get the list. So here is my train of thoughts. I'm gonna need the length of the unique element, length of unique element, and I'm gonna also need a hash map where I will have a hash. Inside the hash, I will have basically a counter where I have the count of each element. And then I'm gonna need to know what is the max of the max occurrence. The element, the max occurrence. No, I'm ready, right? Okay. And then I'm gonna have to do a loop. I guess it's gonna be a nested loop. The first loop will be on the max occurrence. Again. Oh. Okay. Oh. And then a loop on the hash, where I loop, I will reduce the count inside uh, of them. So let's try to code it. Anyone wanna say anything? Come on, people. Anyone wanna say anything before we try to code it? Okay, no one has anything to say before we attempt at a code. Okay. So let's leave this for now. And please don't worry, I actually did write the code for this one, so I am okay. So let's say is a count equal counter from collection and tasks, and let's print count, and let's see. So as you can see, can I just make this and then the counter gave us basically a hash. Now let's try to get the most common. So let's say max f will be count dot most common, and then I will say 1, and we will print it max f and see what it will give us. As you can see, it gave us an array with one element, and inside of it a tuple with the element and the count of it. So in this case, it gave us this element a with 5. So let's go with make it access 0 and then 1, and then let's hopefully give us 5 this time. And as you can see, it only gave us 5, the 5e we have. So let's try to actually solve it. I will say idle equal. I will start to add len tasks, all the len tasks, because it's not gonna be less than the length of the tasks. It makes sense. I will not take less time to finish all the tasks than the whole tasks. So I will need to at least have the len tasks. And then for I in range max f minus 1, I will give total equal 0, and then for key in count, if count bigger than 0 of the element, then total will increase it by 1, and I will decrease the count. Object count key. Count key minus equal 1, and then I will say idle plus equal and minus total minus 1. And let's return the idle. And let's run it. As you can see, in this case, it gave us a correct answer, and also in this case. But there is one wrong answer because there is one case I haven't even mentioned yet, which is what happened if the cooling period is less than the length of the unique element. So in this case, I have a cooling period of 1, but I have 4 unique elements. So I will just return. I will add it if n less than then count. It will return when tasks. So let's try it. As you can see, it's accepted. But there is another case. What if len is less than? Okay. What if len is less than? It does not pass yet. There is actually 2 edge cases left. So wait the clapping for later. I will just make it clear something. It took about these 2 edge cases I discovered using submitting wrong answers before it finally passed. So yeah, not time for clapping yet. So what happened if len is less than the count, but it's not less than the it's less than the max of the max frequent element. What case I am talking about here? This lovely case right here. The n is 7, but the most frequent is only 3. So I outputted the len of the tasks, but it was not actually the correct answer because there is some it's a very long period of calling. So we will just add this here and n less than max f, and let's take this case here. Let's take this test case and let's test it. Why not? But let's test it before we add this condition for it. Is this the right one? I don't think I did it. Yeah. Oh, test case.
click on use test case and it will add it to the.
Yeah. But I will not bother. Okay. Actually, that is weird. Okay. It's weird, but we actually it passes without the test case. Okay. Another case, if it gave us was here. And in this case, it gave us less than the tasks, which is basically just an edge case. We need to check if idle less than len tasks. In that case, we just return len tasks. When we can just use the test case. Apparently, I cannot copy anything. That's a problem. You remember Sabah?
I believe you're not changing n, so that's an issue even with the
Yeah.
previous iteration.
Yeah.
You still need that and in the if condition.
Yeah. I did have. Oh. That's why I needed the and. Correct. Yes, I saw I did something wrong. And n less than max f. Now, if we submit it, it should pass. And I believe it was faster before, but again, it's okay. Now it's time to do something. I did it before. Oh no, it's faster this time. Okay, I'm good. Happy about that. Now I told you we will do things a bit differently today. So you suffered through my explanation. Now you will suffer through Sabah explanation. Please take the wheel for the same problem before we jump to another problem.
Okay, explaining another variation of the problem of the solution, I guess. Let me a solution, right? Manna, can you please copy your code in the comments? I will be recycling that.
Yeah. Backman already asked for it. And I am not gonna hear of it, Monsif. I will not hear of it, Monsif.
All right. So basically, let's use the same test case that Manna explained with. So we have 5 A's and we have 4 B's and 2 D's, well, 2 C's and 2 D's. Now, this solution is going to be less about going through the tasks, but just having observing how if there's any occurrences that we can see that will make us understand better how to solve this. So for example, the answer to this, patterns is the word I was thinking of. So we will observe if there are any patterns that we can catch to basically solve this. So in this case, we start with an A. That will take us to a B. That will take us to a C. That will take us to a D, right? And I believe the N that we used is 4. So let me just quickly go through this. And then an idle. And we're gonna copy this another time because the other iteration until we have no D's left. But I did not even. Right, okay. Now, in this third iteration, we have run out of C's and D's. So C and D is going to be just idle. And to keep the format, I'll just write I. And then we're going to have another one of this iteration. And then now I believe we have run out of B's. So we have one more A. Okay, so this is our answer. And if we count, it is 1, 2, 3, 5 times 4, which is 20, and then plus 1. So now, in this case, what can we notice? We can notice that we can almost separate this into two sections. We have the first section that looks like a grid, and then almost like a leftovers section. So we can take advantage of this grid, basically, to calculate the number of elements inside this grid plus whatever leftovers we have here. So let's write X here and a Y here. So to basically count how many elements we have in this whole contraption, it is going to be X times Y, which is the grid, right? The surface of the grid, plus whatever leftovers we have, because we cannot add like idle time after this A. This is the end of the tasks. We cannot add any more, right? If, for example, we had 5 B's, we would be adding another B here, right? Because we will be having 2 leftover elements, right? Is this clear so far? Can anybody hear me?
It's not clear, please. It's not clear.
It's clear on my
Sorry.
end.
Okay, what
Please come
exactly
again.
is not clear? Which part?
I'm still trying to grab how it actually works. Like, are we counting the number of? Are we counting this A, B, and C like as part of the idle moments or something?
All right. So we have a task manager. Each task, for example, takes 1 second. Our unit of time is 1 second, and each task takes 1 unit of time. This N is how many units of time need to pass between 2 identical elements, right? Since each task takes 1 unit of time, and we are tasked with calculating how many units of time it should take for this whole thing to basically finish, the idle also takes 1 unit of time. It's basically when we have nothing to do. I cannot put an A here because N is 4, and we have not done 4 tasks. So it's just a placeholder. There's nothing there. We're just waiting. It's a cool down period. So the unit of time is, yes, idle takes also the same amount of time as one task. So this takes 1 unit, 1 unit, 1 unit. And by just counting how many tasks, technically an idle, we counted it as a task, right? By counting how many tasks we have finished, that's basically solving the problem. Is it clear?
Yeah, thanks.
Okay. Is there any other problems, or is it clear so far? All right, I will move on. Now, to calculate X and Y, right? We will be using this. Okay, I know, right, that I'm using 1, 2, 3, 4, 5 tasks in one loop. Why? Because our cooldown allows only n plus 1 elements in each iteration. So if I start by my most frequent task, I need at least four units of time or seconds right? Before I can use an A again. So by default, I need n plus 1 plus this first that we used in each loop that we're doing. So 1, 2, 3, 4, 5. So we're using n plus 1 because I'm using A, and then I have to wait 4 units of time. 1, 2, 3, 4. So in this case, our x, the number of columns that we have, is going to be n plus 1. And that is going to be constant in each of the other problems, except the edge cases, of course. But the number of n is the cooldown time, and you add that cooldown time plus that first element or that first task that you have done. Is that clear? Is it clear? Okay.
Yeah.
All right. Now that we know our n, we're gonna move on to our y. How many rows do we have in our grid? We notice that we start with the most frequent element. So to make it more time smart, I guess, you start with the most frequent element and you keep working your way down to your least frequent element. That is how you start with the most frequent, because it's gonna repeat so many times. Imagine if you started with D and then C and D and C, or like D, C, and then you would have a lot of leftovers from the most frequent elements, and you're gonna have to wait a lot of idle time. You're gonna have to put an A and then wait for idles, and then another A and wait for idles. So to make it like smarter and more efficient, you start with the most frequent. So the most frequent element is gonna, I guess, control how many rows you have, because it is what you start with. So in this case, we have 1, 2, 3, 4, 5 A's and 5 B's, but the most frequent count is 5. We know that 5 is how many rows we could have. So in this case, we have 1, 2, 3, 4 plus your last 5. So we can deduce that you would need your max frequency minus 1. We have 5, so we were gonna at least have 4 rows plus whatever leftover you have. Does that make sense? Yes, no? I can repeat.
100%.
Okay. So it's the max frequency minus 1. Because that 1 is gonna be counted in the leftovers. Oh boy. Good. Now we have our x, we have our y, we can put them inside of our formula, but we also have leftovers. Now the leftovers are, if you notice, are our elements that have this max frequency. So in this case, both of these elements have a frequency of 5. So this is 5 here, we have another 5 here, we have a 2 here, and a 2 here, right? So both these tasks have a frequency of 5. So both of them are gonna end up in the leftovers. If we had 5 C's, one of them is gonna end up here. If we had, for example, 1 6, then everything is gonna be inside the grid except that one element with the most frequency. So this leftovers, let's do some colors. Some green, some brown. All right, so leftovers is gonna be elements, or I guess tasks, of max f. So the tasks that have max f as their frequency. So we need to calculate how many elements have max frequency. For example, how many elements have a max frequency of 5 or a frequency of 5. So let's, I guess, do some pseudocode. So since we have this formula, it's gonna be our result. Let's get some white. So the result is going to be our formula. We can now fill in our formula. X equals max F, or max frequency, and the leftovers, let's put this inside frequency. This can be easily gotten from a while loop. So while we iterate through our counter, so we are still using the counter. So while we iterate through, or count the counter, and we will get only the frequency. So I believe it is items. Could be wrong, or maybe elements. Okay, I'll keep it as items, but I don't remember. So for frequency. Okay, so for frequency in counter.elements, frequency, it is gonna give us hopefully only the frequencies. So 5, 5, 2, 2, and they're gonna be in an array, right? And we know our max F is 5, right? Let's put it here. So max F is 5. So now for the frequency for each one, if this frequency equals our first max F, so if frequency equals max F, then we count it. Then we add it to a count plus equal 1. So in this case, this basically just counts how many of these, how many tasks give us a frequency of 5, or our initial frequency, or our max frequency. Is this part understood? Yes? No? It is math heavy, yes.
Yeah, it makes sense.
Okay, all right. So now this leftovers is gonna be whatever count we have. So we can replace this leftovers with count. And I believe that is all that is needed. So let's take this, and I will also take the code that Menna has worked on. Steal, I guess is a better word.
Take anything you want.
So I will do some surgery. Okay, yeah, you clean that up, okay. So instead now of having our while loop, our for loop, I will take that out. And instead, I will first, nope, not you. I will first calculate our I guess, count of how many tasks have this max frequency. So I will take you, still not the right one. Okay. Okay. So, let's first, before we do this, let's make sure this actually, is what we need. Because I'm still not sure.
I think it should be counter dot values. Yeah.
Values, okay. Let's see. It is count. Even see. Okay, so count.
Or
Let's
count
see.
dot values. Yeah.
All right. Let's
Dot
see what
values.
this does.
Uh,
Hello. Right. Values then.
counter dot values.
Oh, we put count.
Counter.
Yeah.
Counter dot values.
Counter.
Did it count?
No, I believe she called it count.
Okay, it's
So,
count. It's count.
yes.
It's count.
It's values, right? Items, I believe, would give us a list of tuples with both the element and its count. All right. So now that we know this is correct, I need to change the name of this because we're already using it here. So I guess max f count. Yeah, what is so we have a count dot values, and we already have max frac, and I believe, yeah, so now we have our max f count, if I did not make any mistakes. Now we go and we take our formula and we put it up. So the result is going to be n plus 1 max frac minus 1 plus our max f count. All right. And in this case, if result is smaller than length tasks, then you return the length of tasks, else you return our result. Does it make sense before we run it? Yes? No? Answer, please. All good?
Very good.
Okay. All right. Let's run it. Hopefully, no errors from my part. Okay, yeah. That got accepted. So I believe this should be faster since we're not using any long loops. You can still make this even shorter by breaking after you don't meet this requirement. Because, for example, in this case, we know that they're in order of frequency. So it will take the first one, it will count it, the second one, it will count it. And once it is not equal to this, once it is smaller, then you can just break. We don't need to see the rest of the array. So we can add an else here. And you break. Because we do not need anything smaller than the max frequency. Why do I keep... Okay. Makes sense?
Yes, madam.
Good. We're done. I believe we might have done something wrong here. It's off by 1.
Yeah, I was about to say, there's one little problem.
But it's very odd.
I check out that last line where we have that if line 25 and 26. Strike it out first for now and test.
Can you repeat?
I said you should try commenting out line 25 and 26 and let's see if it's still going to work.
5 and 6? Or 25 and 27?
925, yeah.
Let's see.
Let's just see.
Nope, that is still... No. I believe it might be from here then. Or... Print result. And print length tasks. Okay, so it's not that.
That is spooky.
It is. It is. Let's remove this just for fun. Should not. Okay, that doesn't make sense. Are these in order? They should be in order. They are not in order. Interesting. How do we make them in order? Well, that I guess would make. I could swear they were in order at some point. Okay, you know what? I'm not even mad at it. I think they should pass now. Yes, it does. And it is faster. No offense, Mama. Yeah. What is it? I hope that was clear enough.
Well, for those who is not clear, this is the smart solution, Sabah solution, and mine was a dumb solution. So you have variety of ways, but it was good, Sabah. It was very good, Sabah.
Don't say that. Thank you. Thank you. I guess now we move on to the second LeetCode, which I will also explain. I hope you're not tired of my voice. Let's just remove this. Let's move somewhere quiet. Okay.
And Dominic asked you to drop the code.
I shall. Okay. Going on.
Why it's so bright? I don't care what's going on. Just turn it down.
Second, please. Let me get to your okay. Task schedule. Apologies. What is wrong? Why is it so bright? Okay. I don't know what I clicked for it to be this bright, but I will just.
Maybe it is showing that the future is bright.
Are you running for office with those kind of lines?
It's in the comments. Alright. Now we can move on to this letter combination of a phone number. So, given a string containing digits from 2 to 9, inclusive, so 2 and 9 included, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits letter, just like the phone buttons, is given below. Note that 1 does not map any letters. Basically, you have this array, this phone, right? Each button that is, for example, 2 has 3 possible letters. I'm sure we have used this kind of phone before. You click once, you click twice, 3 times. This button can give you 3 letters. 3 letters, 3, 3, 3. I believe 2 have 4 letters. The rest have 3 letters. It's telling us, for example, if our list is, I guess it's in the comments, if our list, for example, of digits is 2, 3, then it's asking us to give it or to output an array of the possible combinations between these two, right? So 2 would be A or B or C, and 3 would be D or F or E or F, right? So the combination could be AD, AF, BE, BD, CE, CF, and etc. And it's telling us to basically return this array that has all the different combinations. We will be taking this.
This was the keyboard we used before smartphone. So for those who are old enough to remember, this was something we did use before, in about 100 years before.
Okay, so
I'm
let's
too young.
take. Okay, all right. So the input are 2, 3, and they're gonna be a string actually, and the output needs to be an array. So let's put this actually there. First of all, we need to write down this, like what each letter or what each number corresponds to letters, right? You can either have a dictionary, you can have a list. I chose to have a list, but it is not like not one of them, I guess, is better than the other. The list could be, for example, just ABC, right? Or it can be, for example, a string with like this, A, B, C. It doesn't really matter as long as you keep that in mind when actually using the string. So I will just call it letters, and I will just put it in a simple array. So DEF, GHI, JKL. I'm doing this because we already have technically the index. 0 in this case would be 2. So it's just 2 minus 0 minus 2. 3 minus 2, 8 minus 2, and it would get you the index in this array. So where was I? MNO. EQRS. EWX. WXYZ. All right, now this is our array. This is gonna be our, I guess, index or constant in this problem. Now, let's take an example. For example, our 2, 3. 2, 3 would give us A for 2, right? If we go one number at a time. Before we start, is the question clear? Or do I re-explain that? Is the problem clear?
Yes.
It is. Okay.
Given a combination of digits, you had to give the permutations of those digits on those old ass phones of Mentalas.
Exactly. Thank you. So we would have B and you would have C, right? Let's put them a little bit far apart. Now, the next, I guess, loop or the next step would be to go to 3, right? Because it's going to be A plus the 3 letters of the next digit. So A would be AD, AE, AF. B is going to be BD, BE, BF. C is going to be CD, CE, and CF. So each letter branches out to the next digits combinations or letters. In the case we have 7 or 9, we would have an extra one because we have 4 letters. But in the case that we have, 3 has 3 letters, so we have 3 branchings. All right. If I copy this here, right, and let's do D, and let's give it a color, right? Let's take this actually. And then this one is going to be also E, and it can also be F. And the same thing for B, and the same thing for C. I'm not going to go there because I still want to branch out with this one. So imagine, so in this case, right, in 2, 3, if you just do the same thing with this, BD, BE, BF, CD, ECF, it would give you the combination. It is exactly this, AD, AE, AF, BD, BE, BF, CD, ECF, right? If we have an extra letter or an extra digit, for example, we have a 4, then we will do the same thing we did here for each one of our branches, right? So for D, let's take this. Let's group it. Let's bring it a little bit down. And then let's do the same thing, right? Let's give it, since 4 has 3 letters, then it's gonna be 3 branches, and it's gonna be the same. So here, here, and here. And then the third letter is gonna be each one of these letters. So G, H, okay, no. Let's do this here. Okay, so G, ADG, right? And let's give it a different color. Let's give it green. And here ADH and ADI. And again, it's gonna be the same thing for every single one. So AE is also gonna get these 3 letters. AF is gonna get these three letters, and same for B and same for C and their branches. Does this make sense?
Yes,
And we
ma'am,
can
it
still
does.
keep going. And we can still keep going. 5, then we branch each one to 3, and it's the same. Is it clear? And do we see a way of doing this?
A nested loop comes to my mind.
We could do a nested loop, or we could do recursion. We love recursion, right? We could
Of course.
exactly. So we can do a recursion. This sounds like the same process over and over again with different arrays. So this branches into 3, and then each one branches into 3, and then each one branches into 3. Sounds like some sort of recursion that we can definitely use. All right. So let's take these letters that we have, put them here, and let's start writing some pseudocode in white. All right. We can start with, for example, we have our digits. We can either, I believe you could, I guess, take them and I guess prep them, maybe split them into like actual numbers, put them in an array, or we can just leave that and just go through these digits. So if you loop through these digits, each one would give you a number. You can go and look for that number in our array, and not our array, in our letters array. So the index would be, for example, 2 minus 2, which is 0, and the letters for this number are ABC, right? So you first loop through the digits, then you loop through the letters, and you somehow add these letters to whatever is left of the previous iteration. So, for example, AD is returned from this iteration, and we append these letters to it. Right. Let's start. So we can loop through bits to get the letters, right? And then we can loop through the letters to keep adding them to whatever return we have. Okay, let's start making our backtracking function. So I guess we call it def backtrack. And it should take arguments. We'll get to those later. Right. Now this backtrack should have access to, for example, a result array. For example, an empty result array. Now this result array is going to should have the previous iterations results, right? So let's say it already has gone 2 iterations, and the third one is gonna receive this array. It's basically gonna receive this one. And it's gonna have to work with this one. It's gonna have to go through each element of this array, the previous return, and append 1 or append 3 letters to each one. You can either do that in place, right, by adding those at the end and then pop in this one, or you can make a new array, right, that holds just your results. So this could be your actual base, and the result is going to be returned here. So this one should have the base, because you're going to have to pass the base. Since we will put this inside of a loop, then we need the index, right? The index of these digits. So which digit are we in? Basically, you start from index 0, and then you check index 0, you have a 2, you do your little calculation, 2 minus 2 is 0, then you get your letters, and then you loop through. First of all, you loop through this output, or this base that we call here. We loop through it, each one, you duplicate it. So this one becomes 3. So for example, AD, you duplicate it 1, 2, 3, you append GHI, and you put whatever you have done inside of your results. You return this result as a base for, well, not this result, you pass this result as a base for the next iteration. Let's write that actually so it makes more sense. So in this case, from the index, you get the letters, right? And then you loop through the base, right? And append each letter, or I guess you loop through the letters, these letters, not the big letters, I guess you can call them this phone letters. So you loop through these letters, right? This is a string, or it could be an array, it could be anything. So you loop through these letters, the letters, and append the letter to our combination in the base, either in place or inside our results. So we can initialize a result array that is going to hold our results. So for each base combination, you append the letter to the combination and add it to the result array. Does it make sense? And I believe we are not done, since we are going to have to pass, or I guess call the backtrack again. Call backtrack on the new result, on this result, as a base. So the next iteration is gonna use this result as their base that they're gonna add, and then this new result is gonna be a base for the next iteration, etc. So you can call the backtrack on result with the index +1, since you are now moving to the next digit. So the index is the index of the digits, and you return it, or you can just either like res equal, or just return the call. Does it make sense? A zip. I actually have not thought of doing that.
Yeah, it's just the permutations bit. I just remembered now that zip does something similar.
I might actually look that up, but maybe not right now. But does this make sense?
Absolutely. Well, at least to
Anybody
me. Kindly state if it doesn't for you.
Or we might move on and you won't understand it. So. Okay, I hear silence, so I guess it's all understood. We can take this and our phone letters and we can actually write some kind of code. So we put down our phone letters and then we put down our pseudocode. Okay, let's put that inside actually. Yeah, so it can be called. All right. Now our first phone letters have our letters for each phone digit, and then we have our backtracking function that like this. Okay, from all right, you know what? Let's keep that. From the index, you get the letters. So I guess the letters string is going to be equal to the index, which is the index of these letters. So this, for example, is 2, right? For example, here, digits. Okay, let's use this. The index 0 of this string is 2, right? So digits, is anybody speaking? No? Okay. So the digits index is gonna give us our letter or our digit, but this is a string, right? So we need to make it into int. So int digits index is going to give us 2. Index plus 1 is going to give us 3 as a number and not as a string, right? Now we know that 2, we need to, from this, find it as an index in here. We want to know the corresponding letters to this 2, right? Since we're starting from 0, and here we're starting from 2, there's going to be minus 2. So in the first case, 2 minus 2 is 0. Then the index 0 is ABC, which is correct. For 3, 3 minus 2 is 1, and it's correct because it corresponds to DEF. So this letter string will give us these. It could either be ABC, DEF, etc. So now we loop, we initialize our result array. We loop through the base. So I guess for each combo, no. For combo in base, yes. For combo in base, now we loop through the letters that we have, this letter string. So for letter in letter string, we need to append this letter to the combination. So combo is, for example, going to be AD or just A. So new combo equals combo plus letter. We concat both of them to get the new combo. Now we're saving this new combo in a new result array that we have initialized here. We're not gonna add it in place in base. We're gonna add it in the new result. So let's remove this, and now res dot append our new combo, right? And we should be returning a call to this callback. Backtrack, yes. So we need to call this backtrack with this new result as base and with the index +1 to symbolize that we're moving on to the next digit. So we return backtrack with the result as base and with index +1. Now we just need to call this from our function, backtrack, return, backtrack. Now, if we pass an empty array like it's gonna be in the beginning, right? Our array should be empty, the base in this case should be empty, right? But if we pass it an empty array with no elements on it, it's not gonna enter this for loop because it's empty, no elements. And we want it to append, to go through the combos and append. So instead of passing an empty array, you pass an array with an empty string because it's gonna append the letter to the empty string and it's still gonna be correct. So now you give it base and you give it the index, which is 0. And I believe I should be adding some sort of condition here to return base if the index is far beyond the length of digits. So we don't here check if index +1 is going beyond the limits or not. So we can add it here. So if index is bigger than the length of digits, so just to make sure that we're not moving beyond our digits element or limit, I believe then you return base. I believe should be -1. Yeah, -1. Is this correct? Is this like, does this make sense? All right. For int object is not iterable. What is not iterable? Letter string is not iterable? Oh, yes. This should give us just an index. We need to actually find.
It's not.
Yeah. So just like this. Is. Yes, okay. So does this make sense so far? Before we actually move on. Now the base, they give us an empty string and we should return an empty array. But instead we returned an array with